What is CNC machining? Today, CNC manufacturing is used across all industries and sets the standards for speed, precision, and tight tolerances. CNC machining is a computerized manufacturing process in which software and code controls the movements of the machine. Design engineers enter a complex model into specialized software, which then outputs the code that controls CNC machines. The machines produce the parts based on the constraints that the programmer has outlined in the software. The language used to program CNC machines is called G-code. 1. Reduce costs. CNC machines lower production costs, reduce energy costs, increase scalability, and minimize material waste. 2. Increase efficiency. CNC machines reduce production time and improve product quality, which improves overall manufacturing results and eliminates bottlenecks. 3. Minimize waste. Because CNC machining software is so precise, the machining process results in minimal waste during the manufacturing process. Last, streamlined assembly. CNC machine parts are easier to assemble. The common operation types in CNC machining are as follows. CNC milling machines moving rotating multi-point cutting tools to remove material from the workpiece. Drilling machines use multi-point drill bits to create cylindrical holes in the workpiece. Many CNC machines work by rotating the workpiece material around a primary axis. Cutting tools on the lathe remove material from the workpiece with precision and speed. Before understanding CNC machining, you need to first understand the key components of the CNC machine. The spindle is the core of a CNC machine, providing torque, speed, and control for machining. Input devices enable operators to load CNC programs into the machine. Common types include keyboards, memory devices, wireless Ethernet connections. The machine control unit MCU interprets code from input devices and converts it into motion instructions for the tool drivers, while also processing feedback from sensors. Machine tools shape a workpiece through controlled relative motion, either by moving the tool milling, the workpiece turning, or both multi-axis machining. The drive system provides precise axis movement using servomotors, ball screws, and linear guides. To ensure machining accuracy, the feedback system monitors and corrects the drive system's movements in real time. The display unit serves as the operator interface, presenting critical data and real-time machine status. Successful CNC machining depends on the quality and reliability of the machine tool components. WMT CNC might be a good choice for you. Contact us today to learn more about our high-quality CNC machining components and services.